Welcome back from spring break, A1Gers. It's time to start learning about quadrilaterals. You probably know something about quadrilaterals already from junior high. You've probably learned about squares, trapezoids, parallelograms, maybe a rhombus, kite, isosceles trapezoid perhaps. The goal of this unit is to take your understanding of quadrilaterals and their properties deeper. Guess what? We don't want you to memorize the properties. We just want you to know how to use them and apply them. So, on the test, you're going to get this quadrilateral summary sheet. It's two-sided. It's got all the rules written out. So don't worry about memorizing. Let's just worry about applying these properties. You'll use these properties to answer questions like the following. Describe the best name for this shape. And find the missing angle measures in this parallelogram. Finally, you'll be using these properties of quadrilaterals to construct 7 quadrilaterals on GeoGebra. Let's get this straight. A construction is a drawing of a shape using tools such as a straight edge and compass that creates congruent segments and angles without using a ruler. We're not going to do the pencil and paper version. We're going to use GeoGebra. On GeoGebra, construction can be manipulated and still maintain all of its properties. We'll be in the computer lab for 3 days this unit. Each night you'll have book homework that uses the quadrilateral properties you were using on GeoGebra to solve problems. This project is worth 15 test points and is due on the day of your test, Wednesday, April 10th. You'll be given a rubric so that you can assess yourself all along the way. You're going to get points for using all of the properties. You're going to get points for doing your constructions properly. And I'm going to walk you through all of that in a couple minutes. You're going to make 7 quadrilaterals. I'm going to show you and walk you step by step through constructing a parallelogram. Then you're going to use that knowledge to construct the rest of your shapes. You've got a rhombus, rectangle, square, trapezoid, isosceles trapezoid, and kite. So there's some misconceptions about constructions on GeoGebra. A lot of times students just want to make their constructions based on looks, but I don't want you to do that. For instance, students try to make a square by using the grid. You line up the points and it looks good. It looks like you've got nice straight horizontal lines and nice straight vertical lines, and that looks like a square. When I grade your projects, I'm going to take the arrow tool and drag the coordinates, the vertices around, and see if they maintain their properties. When I drag this point, it's no longer a square, so this construction is incorrect. So let's start over. Let's try to make a parallelogram. What we've learned about parallelograms is that they have 2 pairs of opposite sides parallel. It might help you is if you turn off the axes and turn off the grid. That way you're not tempted to use those lines as a crutch. First off, you can start by making any segment. And then, since we're making a parallelogram, which has 4 sides, you can make another segment. Here's where you got to start getting creative and using specific tools. Up here, we'll drag down from this tool, the parallel line tool. If you look up here, it gives you the directions. It says select a point and a parallel line. So if I select point B and I select line AC, I'm going to create a line through B parallel to AC. I'm going to do this again. I'm going to select AB and then click on C, and I've made another parallel line. Let me just go back and show a common misconception. Sometimes students click on the parallel line and then they click randomly so that the line looks like it goes through C. You don't want to do this. You want to attach things specifically. What happens when I drag A then is you'll see C is not actually attached to the line. You don't want this to happen. If that happens, just undo. In the upper right hand corner you can press the back yellow button and then select the parallel line tool, click on A, B, and then specifically click on C. Last, we want to select intersect two objects. We want to put a fourth vertex right here. So you can select two objects or click directly on the intersection. You'll see this point is black. That means it's fixed. I can't drag D. That's okay. You can have up to 2 fixed points. The rest have to be movable. So as you can see, when I drag points A, opposite lines stay parallel. When I drag point B, opposite lines stay parallel. And C, the same is true. One of the rules in this project is that you can't have lines for your shape. You have to have all segments. To do this, you can click on the segment tool, segment between 2 points. Click from D to C, and we're going to create a segment. You can't see it right now, but it's there. And then you can right-click on the line, click Show Object, and that'll actually hide it. You can do the same thing for the other line. Show Object. Now I'm going to put a segment in its place. Now you have to show me that all of these properties are true. So besides opposite sides being parallel, we also have to measure. Opposite sides are congruent. So I can click on BD. That comes out to be 4.78. AC is 4.78. When I drag point B, you can see that the sides maintain congruency. No matter what the length is, opposite sides are congruent. Now go ahead and measure both pairs of opposite sides and show that both pairs are congruent. Then we have to measure angles. In a parallelogram, opposite angles are congruent. So you have to click on 3 points to measure an angle or 2 lines. By doing this step, you're actually taking care of 2 properties at once. One property of parallelograms is that opposite angles are congruent. You can see as I drag that that rule remains true. And consecutive angles, such as A and C, are supplementary. So that's accounted for. The last property we want to demonstrate is that diagonals bisect each other. A diagonal is a segment that goes from one vertex to its opposite vertex. If they bisect each other, it means that each half of the diagonal is congruent. So we need to create a point right here, and we need to show that AE is congruent to ED. So we're going to take the measure tool again, and if I click on this diagonal AD, it's going to give me 8.28, which is the measure of the whole thing. I don't want that. I just want to show that each half of the diagonal is congruent. So AE is 4.14, ED is also 4.14. Go ahead and measure EC and EB. And then once again, check all of your blue points. Your blue points are your movable points. Drag the shape around and make sure that all the properties remain true, and then you know that you've created a parallelogram. Now you can use these tools to construct other shapes like the rhombus, kite, trapezoid. Other things you might want to be aware of is the perpendicular line tool. That one will help you out. And think about the transformations unit we just came from. This talks about reflecting an object about a line. You could rotate an object around a point or translate an object. So you can use things that we've learned in previous chapters to help you make these constructions. I've got a few helpful links that you might want to check out as you're doing this GeoGebra project. This first link is especially helpful. Special Quadrilaterals has already constructed quadrilaterals on GeoGebra so that you can check and see if your shapes are acting the same way that they should. The only one that's not listed on this website is the isosceles trapezoid, but I think you can figure that out. Then the last one is fake squares, and as I talked about on the grid, don't go based on looks. This fake squares website gives you some examples of shapes that look like squares, but when you drag their corners, they don't remain true. So be careful of that. You have the rubric so you can grade yourself, and we'll be learning a lot about quadrilaterals as we do the GeoGebra project. Good luck!